Hello friends, today's topic of discussion is measures of central tendency, that is averages. Up till now we have discussed how to collect raw data through questionnaire or through survey, then how to classify the data in terms of class intervals, in terms of frequency distribution, and then a classified data can be represented with the help of graphs and diagrams. So how to draw histogram, frequency curve, frequency polygon, Wagh curves, also to draw bar chart, pie chart, and many other types of curves such as Sem-I chart we have discussed earlier. Now once we have presented the data in a graphical manner, the next step is to find the center of the data, that is to find the point around which the whole data is said to be concentrated. So the point of concentration of data is nothing but your characteristic, which we call it as measures of central tendency. So in this lecture we are going to discuss what do you mean by central tendency of data. Then the central tendency of the data is nothing but average. That average can be either arithmetic mean, mode, median, or geometric mean, or harmonic mean, or weighted mean. So discuss the various types of averages. Further, the characteristic of statistical average is to be good, to be decided on which background, that we will discuss in this particular lecture. Further, I will give the definitions of arithmetic mean, then properties of arithmetic mean, that is arithmetic mean is change due to change of scale and origin, how to find out the combined mean for a group of observations. To discuss, we will discuss the merits and demerits of arithmetic mean. One another type of mean is now in your syllabus, that is find the trim mean. Further, the two positional types of averages, that is mode and median, with their definitions, how to find out mean and median for group and ungrouped frequency distribution, then discuss the merits and demerits of mode and median, and some empirical relationship between mean, median and mode is given in this lecture. Further, we will discuss some partition values known as quartiles, deciles and percentiles, how to draw a box plot, that we will decide here. Further, the definition of and formula for geometric mean and harmonic mean is given in this lecture, and accordingly you need to compute all these means for given data set. Now I will have a brief you can say revision whatever we have discussed up till now. So what is your statistics? Statistics is a branch in mathematics which deals with collection, interpretation, organization and interpretation of the raw data. Further, the statistic as such is again divided into two main branches. The first one is called as descriptive statistics, in which we describe, present, summarize and organize raw data which is obtained from the population, and these are numerical calculations which further graphs and tables are in descriptive statistics. The second type of branch in statistics is called as inferential statistics, and in this we discuss more complex mathematical formulas, and we try to find out the trend in the data set. Also we make certain assumptions and predict what will happen to these particular values in future, or prediction for the future things is called as inferential statistics. Further, the different types of data sets we have discussed are either quantitative type of data. Quantitative type of data is obtained through the process of measurement or counting, while qualitative data is associated with some quality or property of observational unit. Further, we have given the definition of logical data, which represents true or false, which play an important role in statistics. Further, one can think of missing data and how the missing data should be allocated, that there are certain techniques for allocating the missing data. So such type of type of things we have discussed earlier. Now again I will have the definition of quantitative data, which is a measurement associated with some certain quality in the data set, and this quantitative type of data is either discrete when the values taken by your variable are in some isolated numbers or which is obtained through the process of counting. Further, continuous type of data is a data which is obtained by the process of measurement, and continuous type of data can take any value in the given interval. So these are two important things which we have discussed, that is discrete and continuous type of data. Now our descriptive statistic is nothing but summarizing the data, classify the data and try to find out the center of the data set, try to find out the variability in the data set. Now we will come to our today's topic, that is central tendency. So what is central tendency? It determines the tendency for the values of your data to cluster around its mean or mode or median. So person analyzes the frequency of each data point in the distribution and describe its mean, median and mode. That is, it is measures of central tendency is a single value from the data set around which the whole data is said to be concentrated. Now there are different types of these measures, averages. Measures of central tendency are also called as averages, and they are either according to their you can say according to the procedure of measuring them, they are partitioned into two things. That is, one is called as positional average and the other one is called as computational average. The positional average is why we call it as positional average, because if you draw your less than type Wagh curve, the value corresponding to n by 12th observation is called as median. So median is obtained by obtained with the help of graph or with the help of Wagh curve, and therefore median is the positional value, position in the sense position in the graph for the true n by 12th observation, that is exactly 50th observation, that is 50th percentile. Further, mode is obtained by the graph which we call it as histogram. So mode is that value for which we can say the frequency is maximum or the most popular observation or most repeated observation is called as mode. So according to its position in the histogram, mode is calculated. Therefore median and mode are called as positional average. Further, our arithmetic mean, geometric mean and harmonic mean are obtained by the computation using some mathematical formula. So according to their computational properties, we have these five types of average, and we will going to study these five types of averages. Now try to understand the data in three different formats. The first format is when we have n individual observations, say x1, x2, x3 up to xn, then this set of x1, x2, xn observation is our original raw data. So we don't have any type of classification or frequency distribution, such type of and such the original data set is x1, x2, xn. So here we have n individual observations. So we will have definition of say arithmetic mean, geometric mean, harmonic mean, median and more for three types of data sets. The first type of data set is n individual observations, say x1, x2, xn. If we have a discrete data sets, say like this 0, 1, 2, 3, 4, and if we have discrete frequency distributions, that means if x takes value 0, 1, 2, 3, 4, say up to k, and at the same time frequencies of 0, 1, 2, 3, 4 are given as f1, f2, f3, f4, etc., then such type of data set is called as discrete frequency distribution. Further, the continuous type of frequency distribution means when we have a data through the process of measurement we have uh, we have classified data according to class intervals. So when we have class intervals, say x1 to x2, x2 to x3, x3 to x4 and so on, and corresponding frequencies are given to you, then we compute xi, that is midpoint of the class interval, and fi is the frequency of that class. So sir, we have generally three types of data sets, and for these three types of data sets, the formulae for arithmetic mean are as follows. What is arithmetic mean? Arithmetic mean is sum of all observations divided by their number of observations. So sum of observations divided by number of observations is called as arithmetic mean. So arithmetic mean x bar for n individual observations is denoted by x1 plus x2 plus x3 plus dash 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 plus xn upon n number of observations. So in summation notation it is denoted by summation of xi upon n. In case of discrete frequency distribution, that is if observation xi repeats for fi times, arithmetic mean is given by summation of fi xi upon summation of fi. Generally summation of fi is denoted by capital N. Therefore x bar is summation of fi xi upon n. In case of continuous frequency distribution, your xi is midpoint of the ith class interval, and formula for computation of arithmetic mean is same, which is x bar is equal to summation of fi xi upon n. Okay. Now one can obtain arithmetic mean using shortcut method also. That is, you take deviations from your observations in case of continuous frequency distribution or discrete frequency distribution. This method is very useful. That is, you take di is equal to xi minus a, where a is any arbitrary value of your convenience. So a is any value you want to subtract from each value of xi, then di is xi minus a, then your arithmetic mean is a plus summation of fi di upon n. So this particular method is called as shortcut method in order to compute arithmetic mean. In case of frequency distribution, these class intervals have suppose equal class width is equal to h. Then you can transform ui is equal to xi minus a upon h, where h is length of the class interval, a is any value of your choice. It is just for convenience. Therefore, in that case, arithmetic mean is given by a plus summation of fi ui upon n into h, where h is called as length of the class interval. So this is shortcut method in order to compute arithmetic mean. We will have this particular example in order to find arithmetic mean. We will have both the methods, that is, first method is direct method and the second one is shortcut method. Suppose we have classes, say 20 to 30, 30 to 40, 40 to 50, 50 to 60, 60 to 70, and these are the class frequencies. Class frequencies are nothing but observations in between 20 to 30 are 8. There are 8 observations in this particular class interval. There are 30 observations having value in between 40 to 50. So in this case, what we do? We first find out midpoint of the class interval. In this case, midpoint of the first class interval is 20 plus 30 divided by 2. Sum of the upper and lower class limit divided by 2, that is 25. Similarly, for the second class, it is 30 plus 40 divided by 2, that is equal to 35. For the third class, it is 40 plus 50 divided by 2, that is 45. Similarly, we can compute it for next two classes. So these are all midpoints of the class and these are all class frequency. What is my formula for computation of arithmetic mean? It is summation of fi xi upon summation of fi, that is n. So here summation of fi is sum of all frequencies denoted by capital N, which is equal to 100, and summation of fi xi is 4600. So my arithmetic mean is m is equal to summation of fi xi upon n is equal to 4600 upon 100, which is equal to 46. If I want to find out my shortcut method, suppose I take deviation x minus a. You can take also one more thing, that is you can take ui is equal to xi minus a upon h. In that case, divide each of this particular value by h. What is your h? h is here length of the class interval, which is equal to 10. Here I have not taken this, but you can take it like this also. So di is equal to x minus a, that is 25 minus 45, that is minus 20. 35 minus 45 minus 10. 45 minus 45, that is 0. 55 minus 45, that is 10. And 65 minus 45, that is 20. If I take Fi into di, that is this particular column multiplied by column of Fi, I have these values. If I take some of the values are positive, some of the values are negative. Therefore, summation of Fi di is equal to 100. So my arithmetic mean is x bar is equal to mean m is equal to a plus summation of Fi di upon n. As now summation of Fi di is 100. So a is my 45. Assume mean 45 plus summation of Fi di upon n is 100. So this thing will be 45 plus 100 upon 100. That is 45 plus 1, that is equal to 46. So you can see that there is no change in value of the arithmetic mean. Either you compute by direct method or by shortcut method. Okay. Now this is again one more problem in which I have taken step deviation method. That means I have taken xi minus a upon I. Actually it should be h. So here what is my length of the class interval? Let the length of the class interval is 11. So what I do first, I take any a is equal to say 38.8. I have taken this value as my assumed mean capital A. Okay, these are my midpoints of the class interval. So 5.5 minus 38.5 is minus 33 upon I, that is length of the class interval 11. So it is minus 3. Similarly 16.5 minus 38.5, which is my A, upon 11, that is minus 22 upon 11, that is minus 2. So this is called as step deviation method. In this case also you can use step deviation method. Similarly for this particular value, see my value of x is 38.5, my value of a is also 38.5. So 38.5 minus 38.5 is 0. 0 upon 11 is 0. So in this way you can compute ui. What is my next step? My step is compute fi into ui, that is f into u column. So these are the values of fu. So summation of fi ui is minus 58. So my x bar is, or mean m is a plus h into the bracket summation of fi ui upon n. So my h is 11, minus 58 is summation of fi ui, n is equal to 103. Therefore my x bar is equal to 38.5 minus, because of this minus 58 I have minus sign here. So value of my arithmetic mean is 32.306. In this way we can compute arithmetic mean for given distribution. So this is an exercise for you. So obtain, here there are marks obtained by 9 students in statistics are given below. So these are the observations 52, 75, 40. So let us have comma here. So what is my arithmetic mean? Arithmetic mean is sum of all these observations divided by number of observations, that is 9. Now in this case this is my discrete frequency distribution. Here variable x takes value 6, 7, 8, 9 isolated values. Therefore this is discrete frequency distribution with frequency is this. So here what formula you are going to use? You can take the first method. Let us take a is equal to 9. Let us take a is equal to 9. So that in this case let us take a is equal to 9. So I have my values of x are here 6, 7, 8, 9, 10, 11, 12. 6, 7, 8, 11, 9, 11, 12. And my a is 9, midpoint. A is 9. So my first value will be 6 minus 9, 7 minus 9, 8 minus 9, 9 minus 9, 10 minus 9, 11 minus 10, 9 and 12 minus 9. Then I just compute summation of fi into di. Di's are my minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4. You just compute summation of fi di, and my taking a is equal to 9. A is equal to 9 in this expression you can find out. arithmetic mean of the distribution by shortcut method. And for this method you can use this step deviation method to find arithmetic mean of this data set. Okay, there is one more mean which we call it as trim mean. Trim mean is a measure designed to address the sensitivity of the sample mean to extreme observations. That means sometimes there are observations which are at extreme, and those observations definitely effect on your arithmetic mean. So when we have a very extreme observations, or you can say those observations are somewhat very much away from your center, then you can delete those observations, and by deleting the extreme observations from both ends, either from lower end or from upper end, whatever you will obtain is called as trim mean. And this trim mean is very important when you have observations which are extreme observations, and these observations are if because of some error or because of some mistakes, one can get rid of those observations by trimming the mean. I will take the definition as well as the example of trim mean afterwards. Now, what are the properties of arithmetic mean? The first and most important property of arithmetic mean is that the sum of deviations of all observations from arithmetic mean is always equal to 0. That means if in this example you just write here you compute arithmetic mean for all these observations: 52 plus 75 plus 40 plus 70 plus 43 plus 65 plus 40 plus 35 plus 48 upon 9. Whatever mean you will get, you take deviation of each observation. You take deviation of each observation from that arithmetic mean, and if you take sum of all these deviations, sum of all these deviations will be equal to 0. Now we will prove this property using your corresponding frequency distribution. Suppose you have n observations x1, x2, xn with corresponding frequencies f1, f2, fn respectively. Okay. Now what is my sum of deviation? What is my deviation of xith observation from mean m? So let us take it is equal to small xi. So small xi is equal to xi minus m. M is my arithmetic mean. If I take sum of deviations of all observations from my arithmetic mean, that is summation of fi into small xi. And what is my xi? Small xi is observation xi minus mean m. Okay. Now if I take this sum in two terms, the first term is summation of fi xi minus second term is summation of fi into m. M being constant, which is independent of I, you can take outside summation sign. So this is equal to m. Actually this is summation of fi xi. So what is my summation of fi xi by definition? My summation of fi xi is equal to, what is my summation of fi xi? Summation of fi xi is n into x bar. Summation of fi xi is n into x bar. So you can take this here. Summation of fi xi is x bar is my m into n. Okay, n into x bar. And if you take m outside, summation of fi is n. So it is m into n minus m into n, which is equal to 0. Okay. So in this way you can show that sum of deviations of all observations from arithmetic mean is always equal to 0. Okay. So for the given set of values here, you try to find out arithmetic mean, and using arithmetic mean you just check whether this property is true or not. That is, sum of deviations of all observations from arithmetic mean is always equal to 0. In the second lecture of this, we will discuss harmonic mean and geometric mean, and also we will discuss some properties of arithmetic mean, geometric mean and harmonic mean. Further, we will take some examples of geometric mean and harmonic mean, and we will try to solve some problems using geometric mean and harmonic mean. That is, we will try to find out the situations where geometric mean and harmonic mean are appropriate. Okay, so thank you and thanks once again.